Hi, I'm Jack McSweeney. I'm going to talk today about patterns of surface temperature variability in the Delaware Estuary. This is work I've done with collaborators at OSU, including Melanie Fewings, Craig Rizian, and Jim Lerczak. In this figure on the left here, you see sea surface temperature data measured by satellite. This is a snapshot, so we're looking at June 17th, 2021. And in this case, you see warm temperatures up estuary compared to relatively cool temperatures at the mouth and in the ocean. And this is, again, just a snapshot. And today we're going to talk about what the patterns of temperature variability are in the estuary along the axis of the estuary and how this varies in time. So the motivation of this work is the fact that temperature variability in estuarine environments have really important impacts on the local ecology. However, temperature variability has been relatively understudied because it isn't as dynamically important as salinity is. So the objective of our work is to describe the temperature variability in the estuary over a range of timescales. So today we're going to show data that allows us to discuss interannual to tidal timescales. Here's another map of the study site, and I'm showing the different sources of temperature data that we are going to use. So the red triangles show moorings, 3 moorings, the A, C, and D site. These moorings were deployed for the majority of 2011, and they include temperature sensors at the surface, mid-water column, and near the bed. In the purple squares, I'm showing the NOAA sites that have surface temperature data only, and most of these sites have data since 2004. Though I'll note that the ocean site 44009 has data from 1984 onwards. So for this talk, we're going to focus just on surface temperature data. We're mostly going to talk about data from the 3 NOAA sites. So the first site we'll talk about is here in the northernmost site. That's the tidal river site. So the salt intrusion front typically resides somewhere between moorings C and A. It changes seasonally in response to river discharge. But up here at this northernmost site, it's always fresh, but it is tidal. So that's the tidal river site. The mid-estuary site is highlighted here. And then what I'm going to call our mouth site is actually the average of these 2 data sets. We're also going to use surface data from the A, C, and D moorings. These cover the mid to upper estuary and just helps us resolve what's going on sort of mid-estuary a little bit better. So let's dig in. This is a time series of the mid-estuary NOAA data. We're looking at sea surface temperature from 2004 to 2022. The first thing that you'll notice is that the seasonal signal really dominates the temperature variability here. We see surface temperature variability on the order of 30 degrees Celsius mid-estuary. And that's on a seasonal time scale. We zoom in on 2011. So this is the year that our moorings were deployed. You can see that on the days to weeks time scale, you have temperature variability somewhere between 2 and 5 degrees. If we zoom in on just 2 months of data to really get a better look at the tidal time scale, you'll see that tidal variability is on the order of 1 to 2 degrees Celsius at this location. So we'll go ahead and add on the tidal river data now. And looking at the middle panel, what I'll point out is that there's greater variability in the days to weeks frequency band. The variability is still on the order of, it's on the order of 2 to 5 degrees, sometimes even as large as 10. So in an example like this. The tidal variability in the lower panel, you can see, is muted at this site. So it's closer to 1 degree. If we add in now the mouth average data, you'll see that, again, my cursor here, looking in April to June timeframe, the variability in the days to weeks frequency band is is reduced relative to what we saw at the tidal river. But interestingly, in the fall, you see a very similar range of variability in that days to weeks time scale. So, so the variability in that days to weeks time scale is quite interesting at the mouth. At the mouth, you also see that the tidal range is actually bigger. Tidal variability is bigger than at both the other sites. That's unsurprising. So now I've just added the mooring data, which here is noted in these sort of green hues and yellow as well. And this allows us to get increased spatial resolution within the mid-estuary, which is going to be helpful moving forward. So now I've just replotted that year again with this little cheat sheet map with the colors to give you a sense of the stars or the NOAA sites, and then the green and blue hues here are the mid-estuary mooring sites. So the one thing I want to point out is that if you look at the purple line, which is the mouth, and the orange line, which is the tidal river, here in the spring, those two lines are cooler than the signal mid-estuary. And you can see that all the way through May, all the way through September. So that is indicating that there is a long estuary maximum in surface temperature. I'm going to zoom in on just a week in May and demonstrate that a little bit more. So I think the zoomed in picture is a little bit more obvious, right? Your purple and orange sites, again, your mouth and tidal river are about 2 degrees cooler than the surface temperature signal mid-estuary. If we contrast this with a week of data in the fall, in this case, we have the warmest temperatures at the mouth and cooler temperature at the tidal river, and you see this mid value at the mid-estuary site. So in that case, there's no change in the sign of the along channel surface temperature gradient. So there's some seasonality to that mid-estuary peak in surface temperature. Another way to look at this is to plot the temperature difference between the tidal river and mouth site. So this is data from 2009 to 2022. And in this framework, if the signal is positive, that means it is warmer upstream. And I've noted the winter months by these blue shaded boxes. I'm shading December through March. And so what you'll notice is that there's this seasonal reversal in the along estuary temperature gradient. So in fall and winter, the tidal river is colder than the mouth. And in the summer, the tidal river is warmer than the mouth. To get at the mid-estuary temperature maximum, we're going to similarly plot the temperature difference between the tidal river site and the mid-estuary site, that's in red, and the temperature difference between the mid-estuary site and the mouth. So if the black line here is positive and the red line is negative, that indicates that there's a mid-estuary warm signal. So here's a good example, summer of 2013. You see this negative signal, red signal, and this positive black signal. So if you want to pause your screen and pause this talk and take a peek at this data, you might notice this pattern where you see at times the mid-estuary is warmer than both the tidal river and the mouth, but that mostly happens in summer. But actually this upstream pattern, this red line, is kind of complicated. So we'll dig into that a little bit more. Before I move on from that though, I want to point out that when both signals are negative, as this example in winter of 2012, that means there's a consistent temperature gradient along estuary. And so in this case, the mouth is warmer than the tidal river. If you have a positive signal on both, then you also have a consistent long estuary temperature gradient, but the tidal river is going to be warmer than the mouth. Okay, so if we zoom in on here just 5 years and we blow that data up, you can see the variability in this red signal a little bit better at this scale. And you can see that the variability in the upstream temperature difference, so that's again the temperature difference between the tidal river and the mid-estuary, is on the order of days to weeks. And the drivers of this variability is one of the focuses of our ongoing research. Okay, so another way to look at this data, so if we take these long time series and we average the data by year day, so here this is what I'm plotting. So year day on my x-axis and my y-axis is surface temperature. Right now I'm showing the data from the tidal river, and the historic range is shown in the shading, and the dashed line is your mean over that period. So what you see here is that the historic range in surface temperature is somewhere between 5 and 10 degrees Celsius. So here in February, for example, that's closer to 5, but in summer closer to 10 at this site. If we add the mid-estuary and mouth data, you see that the historic range is about the same. You might have a wider range, for example, in the winter months and a narrower range in the summer. So that's kind of an interesting reversal there. But here the real interesting part is when you overlay the tidal river data and the mouth data, and the seasonal reversal in the along estuary surface temperature gradient is really obvious in this way. So here in the summer, you see the tidal river being much warmer, and in the winter, you see the mouth being considerably warmer. Now, if I get rid of the ranges and now I'm just plotting the means, I've just made the lines solid here instead of dashed, just for ease of looking at the data. And I've added in the mid-estuary location. And what you see is in the long-term averages, there is this slight mid-estuary temperature maximum. So that just goes to show you that pattern of there being a mid-estuary temperature maximum is a consistent pattern. Now, I'm going to swap that bottom panel with data from the ocean site, and I'm going to add in, means are now back to being dashed, and I'm going to add in the 2011 data. That's, again, the year that we had moorings in the water, and that's shown in the solid line in all of these panels. And 2011 was a really interesting year, so I'm just going to point out a couple of interesting features. 2011 set the historical low in January and February, both up estuary and at the ocean site. It also set the historical maximum in the summer and the historical low in September in the tidal river, and then the historical high at the mouth in December 2011. So very interesting year to have data, mooring data, and we're going to be digging into that more in the upcoming months. Okay, so just to conclude, I discussed today that the scales of surface temperature variability vary along the axis of the estuary and over different time scales. We talked about seasonal variability being on a scale of about 30 degrees Celsius at all of the sites. The variability in the days to weeks frequency band was about 2 to 5 degrees, but I showed you that this was different from site to site, and even at the mouth site, you saw time differences in that variability. And then there was also tidal variability on the order of 1 to 2 degrees Celsius, but varied between sites. The along estuary temperature gradient, surface temperature gradient, changes seasonally. In the summer, the tidal river is warmer than the mouth, and in the winter, the tidal river is cooler than the mouth. I showed that there's a mid-estuary maximum in temperature compared relative to the tidal river and the mouth in the summer. And our upcoming work is going to be looking at 2011 as a case study and really getting into looking into the drivers of this temperature variability. Okay, that's it for now. I just want to say thank you. And if you have questions, you can email me here.